Hi everyone. Today we're gonna go over the rocks and minerals and Earth's interior review questions. So let's get started with question one. Question one says, which mineral is commonly used as an abrasive? If we're talking about minerals, the first thing you should do is take out your reference table and go to the very last page, which is page 16, I believe. And here are your mineral names, and you can find the uses of all the minerals in this column. So let's see. To find which mineral is an abrasive, let's check all the answers. A, garnet. If we find garnet all the way in the bottom, garnet, the use, it says abrasive right here. So I know garnet is the answer. The correct answer for question number one is A. All right, number two. Which igneous rock formed from magma that cools slowly and is composed of 5% amphibole, 8% biotite, 15% plagioclase feldspar, 37% quartz, and 35% potassium feldspar? So, first, I want to see, or I'm going to notice that it says igneous rock. If I see the word igneous rock, I'm going to go to my igneous rock chart, which is on page 6 right here. This is my igneous rock chart. If I ever hear the word igneous rock, I should go to this page and either look at this chart or this chart right here. So now I have to find the igneous rock that cools slowly. Remember from your review packet or your note packet that if it cools slowly underground, it's intrusive. And if the igneous rock cools fast above ground, it's extrusive. So if this igneous rock cools slowly underground, so I know what the rock that I'm looking for is intrusive. This column up here or row up here shows my extrusive rocks. This row down here shows my intrusive rocks. I'm looking for an intrusive rock. Okay, so it cools slowly and it's composed of 5% amphibole, 8% biotite, 15% plagioclase feldspar, 37% quartz, and 35% potassium feldspar. Okay, so A is rhyolite. Let's see if rhyolite is intrusive or extrusive. Rhyolite right here is extrusive. I'm looking for an intrusive rock that cools slowly, so that's not it. B is granite. Granite is intrusive, so that might be it. C is diorite. Diorite is intrusive, so that also might be it. And D is scoria. Scoria up here is extrusive, so that's not it. So my answers are between granite and diorite, B and C. Okay, so let's see if diorite has all these minerals I'm looking for. Notice that if I look at diorite and I go all the way down here, this area of my chart shows what minerals are in my rocks. Diorite has, if I go down, it has a little bit of quartz right here, plagioclase feldspar, biotite, and amphibole. But notice diorite doesn't have any potassium feldspar in it. Maybe yeah, not even a little bit. So this rock that I'm looking for has 35% potassium feldspar. So diorite can't be it. Granite, however, has potassium. Here's granite. It has potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole. So that must be it. So the answer is B, granite. All right, number three says scoria is a type of rock that formed most directly from which of these processes? So if it ever talks about or asks you about how a rock formed, you're gonna go here. Okay? So remember that sedimentary rocks, if I follow the arrows that point to sedimentary rocks, I see that sedimentary rocks form from compaction, cementation. They also form from deposition and burial, and they also form from weathering and erosion. So an igneous rock can weather and erode, deposit and bury, compact and cement to form a sedimentary rock. A metamorphic rock can also go through weathering and erosion, deposition, burial, compaction, and cementation to form a sedimentary rock. Notice that metamorphic rocks form from heat and pressure. Heat and pressure, they can form from igneous rocks. They can also form from sedimentary rocks. And finally, notice that igneous rocks form from melting and solidification. Metamorphic rocks can melt and solidify to form igneous rocks. Sedimentary rocks can also melt and solidify to form igneous rocks. I'm looking for scoria, right? Let's see what type of rock scoria is. That sounds like a name of a rock, so I'm going to check all my rock charts to find where scoria is. I'm going to look here. I'm going to look in my sedimentary rock chart and my metamorphic rock chart. But I find scoria to be in my igneous rock chart. Okay, so scoria is an igneous rock, which means it forms from melting and solidification. So the answer is A, solidification. Question number 4. What is the texture of an igneous rock formed from magma that cools solely deep underground? Okay, igneous rock. So I'm going to go to my igneous rock chart right here. I'm looking for an igneous rock that cools solely underground. Remember, cools so underground is intrusive. And I want to know what texture that rock has. Okay, igneous rock, intrusive, cools solely underground. Here's my texture column. If I go to the right, the texture should be coarse or very coarse or non-vesicular. So that's why the correct answer is A, non-vesicular and coarse. Number 5. Which graph best shows the relationship between the compositions of different igneous rocks and their densities? If I see the word felsic, mafic, or just igneous rocks, remember I should go here, right? Notice around here, there's mafic and there's felsic. Mafic just means that that rock is made of or rich in iron and magnesium, the density is higher, and the color is darker. These rocks are mafic. Felsic means that's rich in silicon and aluminum, the density is lower, the color is lighter. These rocks are felsic. So overall, mafic has a higher density, felsic has a lower density. That's why the correct answer is B. As you become more mafic, the density increases. B. All right, question number 6. Which chart correctly matches rock salt and rock gypsum with how the minerals from these rocks are used? So let's see. Rock salt, rock gypsum. Those seem like names of rocks. And I'm going to look at all my rock charts, igneous, sedimentary, and metamorphic, and I find that rock salt and rock gypsum are sedimentary rocks. Okay. And I'm looking for the mineral root use, meaning all rocks are made up of minerals. These particular rocks, whatever minerals they're made up of, how do we use them? So here are my rock salt and rock gypsum. To find out what minerals they're made up of, always look in the composition column. Rock salt is made up of halite, and rock gypsum is made up of gypsum. Now that I know these minerals, and if I want to find their uses, as before, I go all the way to my mineral chart, which is on page 16. Halite is a food additive or it melts ice, and selenite gypsum or just gypsum is plaster for Paris or drywall. That's why the correct answer is D. Rock salt melts ice, halite, rock gypsum, plaster of Paris. Okay, number 7, which element is always found in bioclastic sedimentary rocks? If I hear the word sedimentary rocks, I should go to my sedimentary rock chart, which is right here. Or I'll go here. Okay, I want to know which which element is found in a bioclastic sedimentary rock. Here's bioclastic in my texture section. And to find what it's made up of or what element it's made up of, I'm going to go to the composition section. Bioclastic sedimentary rocks are made up of carbon. The correct answer is C. 8. What are the rock name and map symbol used to represent the sedimentary rock that has a grain size of 0.006 to 0.2 centimeters? Okay, so sedimentary rocks mean I'm going to go to this chart and I'm looking for a grain size right here, this column of 0.006 to 0.2. Here's 0.006 to 0.2. That's sand. That's a sedimentary rock made up of sand. And the name of that rock is right here, sandstone. And the symbol that we use on a map for that rock is this. So that's why the correct answer is D, sandstone. And this is my map symbol. All right, number 9. Which medium grain size metamorphic rock is composed mostly of the same mineral as the sedimentary rock limestone? I'm seeing both metamorphic and sedimentary rock in this question, which means I should look at both charts. Okay, I'm looking for a metamorphic rock that is made up of the same mineral as the sedimentary rock limestone. Okay, so this is my sedimentary rock limestone right here in my sedimentary rock chart, and it's made up of calcite. Okay, and which of my metamorphic rocks in this chart are also made up of calcite? Marble, as you can see, it has a composition of calcite. So the correct answer is marble, B. All right, question 10. The diagram below represents geological processes that act continuously on Earth to form different rock types. Rock type 1 is formed from process A, which is weathering, erosion, deposition, compaction. Rock type 2 is formed from process B, which is melting followed by cooling and solidification. Rock type 3 is formed from process C, which is heat and pressure accompanied by chemical activities. Okay, and notice that rock type 3 can turn into rock type 1 by weathering and erosion again. All right, so I want to know which one of each rock type is, or what the name or what rock type is each rock type number. Number one, rock type one, is formed from weathering and erosion. So if I'm just trying to figure out how each rock forms, remember, I just go to this page, page 6 up here, the rock cycle. And rock type one is formed from weathering and erosion. Sedimentary rocks are formed from weathering, erosion, deposition, burial, compaction, cementation. So rock type 1 must be a sedimentary rock. Rock type 2 is formed from melting and solidification. Igneous rocks form from melting and solidification, so rock type 2 must be an igneous rock. Rock type 3 is formed from C, heat and pressure. Metamorphic rocks are formed from heat and pressure, so rock type 3 must be a metamorphic rock, and the correct answer is B. All right, 11. Which layer of the Earth's interior is inferred to be composed mostly of iron and nickel and has an interior temperature that is greater than its melting point? If I'm talking about the Earth's interior or the layers of the Earth, I'm going to go to this page right here. This is page 10. This is the layers of the Earth or the Earth's interior. I want to know which of these layers are made up of iron and nickel. So the outer core and the inner core look like they're made up of iron and nickel. Okay. So, which layer of the Earth's interior is composed mostly of iron and nickel, but also has an interior temperature that is greater than its melting point? To figure that out, I go down here and I see that the outer core, the interior temperature is higher than the melting point. But for the inner core, the melting point is higher than the interior temperature. I'm looking for the interior temperature that is greater than the melting point, so that must be the outer core. That's why the correct answer is C, outer core. Question 12. Compared to the granitic continental crust, the basaltic oceanic crust is this one you can find the density you can find right here. So the granitic continental crust is 2.7 density and the basaltic oceanic crust is 3.0. So the oceanic crust is more dense and the continental crust is less dense. For thinner versus thicker, you have to go over here in your notes and memorize that the oceanic crust is thinner and more dense. The continental crust is thicker and less dense. That's why the correct answer is, compared to the granitic continental crust, the basaltic oceanic crust is thinner and more dense. B. Oceanic crust, thinner, more dense. All right, 13. The map below shows the tectonic plate boundary in the Atlantic Ocean between South America and Africa. Letter A, B, C, and D represent locations on Earth's surface. The most recently formed oceanic crust would be located closest to location. The correct answer is C, because this is a mid-ocean ridge in the mid-Atlantic ridge. And remember, mid-ocean ridges are formed by divergent boundaries, and in mid-ocean ridges, we form new crust. So that's why the most recently formed oceanic crust is location C. 14. What is occurring at the Southeast Indian Ridge? The Southeast Indian Ridge is another type of mid-ocean ridge in the Southeast Indian Ocean. And that's why the correct answer is A. New oceanic crust is forming because in mid-ocean ridges, we form new crust. You can also find the Southeast Indian Ridge right here. I'm not sure how to turn this. Okay. All right, so we're just gonna have to look at it like this. Unfortunate. Oh, I got it. Oop. Okay, here you go. Here's the Southeast Indian Ridge right here, and you can see they form in a divergent plate boundary. This is page 5. This is where you're gonna find all your tectonic plates, your plate boundaries, convergent, divergent, and transform, as well as hotspots. Okay, 15. Which tectonic plate boundary is best represented by this diagram? Notice that this diagram, the oceanic crust is going under the continental crust. We're forming a trench and volcanoes or volcanic arcs. Notice convergent boundaries create mountains and trenches and volcanoes and even earthquakes. So this must be a convergent boundary. So which tectonic plate boundary is best represented by this diagram? I have to look for a convergent boundary in my reference table right here. The correct answer is C, Juan de Fuca plate and North American plate. Because if you look over here, between the Juan de Fuca plate and the North American plate, it's this symbol, and this symbol represents a convergent plate boundary. The correct answer is C. All right. Which type of tectonic plate boundary is found between the South American plate and the Scotia plate? Here's the South American plate. Here's the Scotia plate. This looks like a transform plate boundary. So the correct answer is transform. A. Which 17? Which two mantle hotspots are located at mid-ocean ridges? The correct answer is D, Easter Island and Bavette. Because I'm looking for a hotspot, this is the symbol for a hotspot. Notice that Bovette hotspot right here is on a divergent boundary. Divergent boundaries create mid-ocean ridges, so the Bovette hotspot is on a mid-ocean ridge. And so is the Easter Island hotspot right here. It's on a divergent boundary, and divergent boundaries in the ocean create mid-ocean ridges. That's why it's D. All right, 18. The formation of Canary Islands are primarily caused by their location near A. Let's find Canary Islands here. Notice that Canary Islands is right here, and that means Canary Island is a hotspot. It has this symbol. So that's why the correct answer is B. Canary Islands, the formation of Canary Islands are primarily caused by their location near a hotspot. All right. The world map below shows Earth's major tectonic plate boundaries. Letters A through D represent 4 surface locations. Which location is a major rift valley? Remember, divergent boundary, divergent boundaries create rift valleys. So I should be looking for a divergent boundary. Okay, so this is location D, below South America. That's around here. This is a transform boundary. I'm not looking for that. This is location C. That's somewhere right here. That's a hotspot. I'm not looking for that. This is location B. That's right here. That's a convergent boundary. I'm not looking for that. And finally, this is location A. That's right here. This is a divergent boundary. The plates are moving apart. And notice it also says East African Rift, which is a rift valley. So that's what I'm looking for. Which location is a major rift valley? A. 20. Which two features are commonly found at divergent plate boundaries? Divergent plate boundaries in your note packet create rift valleys, mid-ocean ridges, seafloor spreading, and new crust. So that I'm looking for those things. That's why the correct answer is A, mid-ocean ridges and rift valleys. You should be memorizing the notes in your note packet. All right. Finally, actually, that's about it. Thank you so much. Bye.